Mr. Clan here for Clan Maths. This is the SQA Higher Maths Essential Skills Paper 2 for 2025. 1.5 hours long and 65 marks. Quite a strict, harsh marking here from Mr. Reddy, but hopefully you find this useful. Remember, if you are struggling, we've got the Higher Maths last minute live stream for exam prep on Sunday the 11th of May, the night before the exam, and it is only £4.99, so click join now to get on that. My Maths is sponsored by Lecky, the educational publisher for Scotland. Now, going from National 4 to National 5 Maths can be quite a difficult thing for a lot of pupils. That's why Lecky have got National 4 to National 5 Maths Bridging Skills book. This revises everything from National 4 to help you prepare yourself for National 5. It's got questions on every topic, it's bright and colourful, and it has hints and tips and work solutions to everything as well. This is just £6.99 when you use the discount code CLERONMaths. I highly recommend it if you are now moving on to National 5 Maths. CLERONMaths at leckyscotland.co.uk. Link is in the description. SQA Higher Maths 2025 Essential Skills Paper 2, Question 1. The vertices of a triangle are P, Q and R as shown, minus 3, 5, 1 minus 7 and 15, 1. Find the equation of the altitude through R. So there's R here. Altitude meets the opposite line at right angles. So we're looking for a line that cuts this at right angles. So I'll just kind of draw that to show you. So that means that I need the gradient of PQ, then M1 times M2 equals minus 1. So we're going to start there. So for question A, we've got minus 3, 5. And for Q, we have 1 minus 7. So the gradient of PQ is minus 7 minus 5 over 1 minus 3. That's minus 12 over 4, which is minus 3. And therefore, the gradient of the perpendicular equals, well, it's a negative reciprocal. In other words, you flip it upside down, that's a third, and then you change the sign. So it's still a third because M1, M2 equals minus 1. You always want to have that statement. So we've got a gradient, we need a point, so we can pick the point R. R is 15, 1. That's our A and our B. So we've got Y minus B, which is 1, equals M, a third, X minus A, which is 15. So then we can solve that. Y minus 1, I'll leave that as a third X, because the third goes into 15, so it's actually quite easy. 3 5 is 15. If it didn't go in, I would take a 3 up to the other side. So that means that Y is equal to a third X. Minus 5 add 1 is minus 4. And we're done there for part A. Part B says, find the equation of a median through Q. So median through Q means starting at Q, go to the opposite side, and it cuts it in half. So I need the midpoint of PR, and that'll give me this point here, let's call it M, and then the gradient of MQ, and then Y minus B is M, X minus A. So P and R, minus 3, 5, 15, 1. So the mid of PR, well, I can just add the coordinates up, divide by 2, add, divide by 2. 15 minus 3 is 12, divided by 2 is 6. 5 and 1 is 6, divided by 2 is 3. So there's my midpoint. And then using the other point, which is Q, 1 minus 7, I'll just call this mid PRM. We want the gradient of M to Q. So minus 7 minus 3 over 1 minus 6, minus 10 over minus 5, 2. So we've got a gradient, now we need to pick a point. So we can pick M or Q. Well, M is easier because it's just all positive. It is 6 and 3. So using 6 and 3 for my A and my B, I've got Y minus B equals M, X minus A. Expanding that out, Y minus 3 equals 2X minus 12. So Y is 2X minus 12, add 3 is minus 9. And we're done there for that question. Part C, calculate the coordinates of the point of intersection between the altitude and the median. So it's simultaneous equations. So let's write down our two equations for part C. We've got Y equals a third X minus 4. And we've also got Y equals 2X minus 9. Now, if you had this as not Y equals the top one, but like say 3Y, as an x and 12, you can still do this. You can just scale up. You can do whatever you want as simultaneous equations. But this is a nice simultaneous equations one for me because they both say y equals. So that means that both sides equal each other. So I can just write a third x minus 4 equals 2x minus 9 and solve from there. So this means that I can move the 9 over to join the 4, add in 9. 9 minus 4 is 5 on this side. And then I've got 2x plus a third x. So that is 2 and a third x. I like that for now, but I'll fix it in a minute. Well, it's actually 2x minus a third x, so that's 1 and 2/3 x. Now I'll fix that for now. I'll change that to a mixed number. That's 3, 4, 5/3 x. So times them by 3, 15 equals 5x. Dividing by 5, x equals 3. And then we just sub it into one of the equations. So just using this one. Y equals 2 times 3 minus 9. 6 minus 9 is minus 3. So the point of intersection is 3 minus 3. And we're done there. SQA Maths 2025 Essential Skills Paper 2, Question 2. The diagram shows the graph f of x with a point at 0 minus 4 and a minimum turning point of 3 minus 6. Sketch the graph of minus f of x minus 4 and then sketch y equals f dash x for derivative. So there's a couple of things going on here. Part A, minus of the function means I flip it upside down. And then take away 4 means I move everything down by 4. So if I just look at all the points that are on it and find out what points they become, I should be good to go. So for part A, the first point I'm going to look at is minus 2, 0. Well, when I flip that upside down on the axis, it still stays at minus 2. But 0 becomes minus 4 because it goes down by 4. The next point you come to is also on the axis, which is 5, 0. So it stays on 5, but then it goes down to minus 4. And then we've got the point of inflection, which is minus 4, 0. Not 0 minus 4, sorry. So if I flip upside down, I'm still going to be on 0 along, but suddenly I'll be up at 4. But then I need to go down by 4, so I'll actually be on 0, 0. And then the last point to look at is 3 minus 6. If I flip that upside down, I'm still going to go along 3, but then I'll go up to 6 because it's upside down. But then I need to go down by 4, so it's 3, 2. So I've now got all my points, so I can draw a nice neat sketch. So let's note the points first, x and y. We've got minus 2, minus 4. I'll just put that there, and I'll just write it. We've got along 5 and minus 4, so I'll just put that there, same height. And then we've got 0, 0, and then we've got 3, 2. So along 3 will be before 5, and then up 2. And then just noting that it's exactly the same graph now, but it's just upside down. So we get a picture that looks something like this, and then that's your point of inflection, and then turning point, and then down, and there's a nice neat sketch. Part B, sketch the graph of the derivative. So to sketch the graph of the derivative, you need to consider, is the graph decreasing, increasing, or 0? The derivative. So if I look here, just draw a little curve there. It's going down, then 0, then down, and then up at those points. And what's happening at those points? Well, so going along the x-axis, before minus 4, it is negative, which means I need to be below the x-axis. And then after at minus 4, it is 0, so I need to be on the x-axis. And then it's negative again, going down the way, so I need to be below. And then it's 0 at 3, so I need to be on the x-axis at 0. And then after it, we go up the way, so that's positive gradient. So I need to be above the x-axis. That's how I think about the graph of the derivative. So let me try and draw this out to see if that's clear to you. I'll draw an x and a y-axis. And all I'm considering is the x part. So before x equals 0, I'm negative. So if I put 0 here, I'm down there somewhere. At x equals 0, I'm 0, so I'm on the axis, so I need a point at 0, 0. And then after x equals 0 but before 3, I'm negative again. So I need to have the number 3 here, and I'm back down there. And then after 3, I'm positive again. So after 3, but on 3, I'm on the x-axis because that's a turning point, and then I'm above there. So you can see here, without redrawing it, that if I go up towards there, I must turn there at some point, and then turn back up. Because I'm on the x-axis there, but I'm immediately below and immediately below there. So just drawing that, and then I need to go down, and at some point, just before 3, I need to turn back up. You don't know where, but I'll just do it there. And then I need to keep going after 3. So it's a rough graph like that. The original equation, that doesn't tell you, but it's probably a quartic, and I've now ended up with a cubic. And we're done there. SQA Higher Maths 2025 Essential Skills Paper 2, Question 3. A curve has the equation f of x is 2 over x plus 1 squared when x doesn't equal minus 1 because you can't divide by 0. Find the equation of the tangent to the curve at the point x equals 1. Okay, equation of a tangent means I need to do differentiation. And when I do differentiation, I get the gradient of the tangent. I put 1 in. And then I need a point to do y minus b is mx minus a. So to get my point, I sub 1 in f of x to get x and y. That is my approach to this. So I've got f of x. I'm going to make that differentiable by taking the x plus 1 up to the top and making it a minus 2. So f dash x tells me my gradient, remember. Minus 2 times 2 is minus 4, x plus 1 to the minus 3. And then I need to work that out at 1. So that's minus 4, 1 plus 1 to the minus 3. Now, I probably want to leave that as a fraction, but you're using a calculator, remember, if you have to. But I'll like that as minus 4, 1 plus 1 is 2 over 2 cubed, minus 4 over 8. That gives me a gradient of minus a half. Now I need a point. So when x equals 1, y, which is f of x, equals 2 over 1 plus 1 squared. That's 2 over, well, 1 plus 1 is 2. That's 2 over 4. That's a half. So my point is 1.5, and my gradient is minus a half. So I can now do y minus b is mx minus a. Y minus b, which is a half, equals minus a half gradient, x minus 1. And this time I will do it by moving the 2 up. So I'll move the 2 in front of the y here, y minus a half. I'll leave the minus 1 where it is, x minus 1. Expand both brackets. 2y, 2 times a half is 1. Minus x, minus times a minus is a plus. And then moving everything so that it's nice and neat. There's 2 ways you can leave this. Move the y and the x to the same side. 2y plus x. And move the number 1 to the other side is 2. Or a nicer way, 2y plus x minus 2 equals 0. You cannot leave it as 2y equals minus x add 2. That's not allowed. You have to have it that form, or y equals. SQA Higher Maths 2025 Essential Skills Paper 2, Question 4. Sonia uses a credit card to book her family holiday. The holiday comes to £3,200 and she pays it on the 1st of September. Sonia now wants to pay the debt on her credit card off. Interest is added. She pays the same amount each month until the final payment. According to the reconciliation, UN plus 1 is M, UN plus C, where M and C are constants, and N is the number of months after September. The balance on the 1st of October was this, and on the 1st of November was that. Use the information to calculate M and C. So we'll just substitute in and do some simultaneous equations. So part A, we know that the holiday comes to 3,200. So that is our initial condition, 3,200. And then 1st of October is 1 month later, so that's U1, equals M, U0 plus C, which equals 2896. And U2, which is the November again, so that's October, November, 2 months, equals M, U1, the one before it, plus C, and that's 258288. So we've now got two simultaneous equations. So let's put in some of the numbers that we've got. So U1 equals mu0. Well, U0 is 3200. So we've got 3200 m plus c equals 2896. And mu1, well, we know u1 is 2896. So we can say that we've got 2896 m plus c equals 258282. So we can just take them away from each other using a calculator. So we get 304m on this side equals 2896 minus 2582.82, 31318. So we divide by 304 to get 1.03 roughly. So m to two decimal places is 1.03. And now we need to work out our c, so we just sub in. So we'll just sub into this one. 3200 times 1.03 plus c equals 2896. That's 3296 plus c equals 2896. So that means that c is 2896 minus 3296, which is minus 400. And we're done there. Part B. Determine the final payment in which month Sonia will pay the holiday off. So, for part B, remember U0 is equal to September 1st, the first month. And then we've got our recurrence relationship. UN plus 1 equals M UN minus 400. U1 was 2896. U2 was 258288. So she's going to pay it off. She has to get a balance of 0 or more than 0, less than 0. So we just need to keep working on this recurrence relationship because it doesn't have a limit because that's not between minus 1 and 1. So we're just constantly subbing in. So we'll just get a calculator. 1.03 times 2582.88 minus 400, U3 is equal to 2260.37. 1.03 times 2260.37 minus 400, U4 is 1928.18. So I go to U5. 1586.03, quite a long one this one. U6. $1,233.61. U7. $870.62. U8. $496.74. U9, you should be able to see it as U10, but need to show it, I suppose. So we've still got a little bit left at U9. So if the recurrence relationship was to keep going, U10 would be the first negative. minus 285.01. Okay, so the final payment, September, October, November, December, January, February, March, April, May, June, July. So it's in July, but how much are we paying? Well, we usually pay £400. So, but we've got a minus balance if we do that. So taking away that, it's actually only £114.99 for your final payment. And we're done there. Now you might get a slightly different answer for rounding if you rounded at a certain point and got 98 instead of 99, but roughly the same, but that is the answer. SQA Higher Maths 2025 Essential Skills Paper 2, question 5. The diagram shows the curve x squared minus 3 intersecting the curve 9 minus 2x squared. Calculate shared area. Okay, x squared minus 3 is the one which is on the bottom, and the one on the top is this one. So I do the top curve minus the bottom curve between these 2 points. So I need to find the point of intersection, okay? So point of intersections, or points of intersection, I've got 9 minus 2x squared equals x squared minus 3. So that gives me 3x squared on this side. 9 plus 3 is 12. So I can divide by 3 to get 4 equals x squared. And then it's the difference of two squares. Or if it's just x squared equals a number, then x equals 4, or x equals, not 4, 2 of course, because a square root, minus 2. So we've got 2 and minus 2, and then it's the integral between minus 2 and 2 then of the upper curve, which is 9 minus 2x squared, take away the lower curve, which is x squared minus 3, so I'll put that in brackets because I'm taking the whole thing away, dx. So then we'll fix that before we even integrate. We've got 9 minus minus 3 is 12. We've got minus 2x squared minus x squared is minus 3x squared dx. And now we can integrate. So integrate means add 1 to the power, divide by the new power. So 12 becomes 12x. Minus, I've got x cubed, adding 1, and then 3 divided by 3 is 1, so it's just minus x cubed. And I need to sub in minus 2 and 2. So I put a 2 in. Now always write out what you're doing, because you get a mark for the substitution. So that minus 2 cubed, take away 12 times minus 2 minus minus 2 cubed. And then if I can't work out the rest, at least I want to lose a mark. So 12 times 2 is 24, 2 cubed is 8. 12 times minus 2 is minus 24, times a minus is plus 24. Minus 2 cubed minus 8, times minus 1 is positive 8, times a minus is minus 8 again. So I've got 24 plus 24, take away 2 8s. So that's 24 48 minus 16, which is 38 32. 32 units squared, because I don't think I actually know what the units are. SQA Higher Maths 2025 Paper 2 Essential Skills. Question 6. Solves 2 cos 2x minus 7 sin x equals 0 between 0 and 360. So I'm going to have to use a trig identity to do all sine or all cos. So cos 2x is 2, and that's 1 minus 2 sine squared x from the start of the exam paper, minus 7 sine x's, 0, so that's a quadratic, 2 minus 4 sine squared x, minus 7 sine x equals 0. So I like to make my sine squared x positive to make it easier, so I'll move everything over to the other side, so I get 4 sine squared x, minus 7 becomes plus 7, and 2 becomes minus 2. So you need to factorize this. That's like 4x squared plus 7x minus 2. It's just the same thing. So double bracket. So you're going to have 2 and 1. Now if I try 4, I'll get 4 2s are 8. And then 1 is 7. So that's going to work. But instead of 4x, it's 4 sine x. And it's sine x. So we've got plus and minus, because that'll give me 4 2s are 8, minus 1 is 7. So we can say that each bracket equals 0. So 4 sine x minus 1 equals 0, or sine x plus 2 equals 0. Solving both separately, sine x on this side equals 1/4, and on this side, sine x equals minus 2. Well, that's invalid. So it's not applicable because sine only goes up to 1 and minus 1. If you try and put it in a calculator, you'll get it doesn't work. So the only one is sine x equals 1/4. Well, we're not working with exact values here. So we're doing shift sine 1/4, which is 14.47 degrees, or 14.5 if you prefer. So x equals 14.5. And then we need to get another answer. So standard way, cast diagram, sine is positive, so I'll do 180 minus. So x equals 180 minus 14.5. Which is 165.5. And we're only to do it between 0 and 360, so there's only 2 answers, so we're done there. SQA Higher Maths 2025 Essential Skills Paper 2, Question 7. Solve log base 10 3x plus 1 plus log base 10x minus 2 equals 1 for x is greater than 2. So rules of logs are like indices. If I see an add, same base, it means I can times. So I can make it 1 log 3x plus 1 x minus 2 equals 1. Now, if it was log equals log here, I could just get rid of the log straight away. Since it isn't, then the base to the power equals this. So 10 to the power 1 on this side equals 3x plus 1 and x minus 2. And now I need to solve that. So I'm going to have to expand it because it's going to be a quadratic because it's squared and get it equal to 0. So I've got 3x squared minus 6x plus 1x is minus 5x minus 2 equals 10. So 3x squared minus 5x minus 12 equals 0. So another quadratic to solve. How exciting. Double brackets, we hope. If not, quadratic formula. So we've got 3x and x. So we're looking for factors of 12. So let's try the obvious 3 and 4 first. If I had 3 3s is 9, and then 4 would give me 5, yeah. That was lucky. But you could just try it, or there is methods, remember, to solve quadratics, especially from National 5 Skills. But we've got 3 3s is 9, so that'll give me minus 9, plus 4 is minus 5. 4 times minus 3 is minus 12. So that means that the first bracket is 0, so x is minus 4/3, or x is 3. But remember, when you're working with logs, you need to watch out. If I go back up here, if x was minus 4/3, I would get a minus log of a minus here, but logs are always positive. It even tells you x is bigger than 2. So that one there is invalid, so that's the only answer. And we're done there. SQA Higher Maths 2025 Essential Skills Paper 2, Question 8. In the diagram, B to A is minus I plus 3j plus 4k. And C to A is 3i minus 6j plus 9k. Find B to C in terms of ijk. So there's my B to C there. So I could go for part A, B to C. I can go from B to A, and then I can go from A to C. So B to A is minus 1i plus 3j plus 4k, plus A to C is the reverse of C to A, so minus 3i, minus 6j becomes plus 6j, and plus 9k becomes minus 9k. Minus 1i minus 3i is minus 4i. 3j plus 6j is 9j. 4k minus 9k is minus 5k. And we're done there for part A. Point D divides AC in a ratio of 2 to 1. Show that BD is that. So we're going to go from B to D. So we still need to go from BA. So B to D equals B to A. Plus, we're going to go along AC again. But how far along? We'll divide it in a ratio of 2 to 1, sorry. So that's 2 parts and that's 1 part. So in total I've got 3 parts and I'm going along 2 parts, 2/3. So we've got BA, which we already know was -1, 3 and 4, plus 2/3 A to C, which we already know was -3, 6 and -9. We've just got it like that, so it's for clarity. So that's -1, 3, 4, plus, divide by 3 and times 2, -3, -1 times 2 is -2. 6 divided by 3 is 2 times 2 is 4. 9 divided by 3 is 3 times 2 is 6. So that equals -3, 7 and -2. Or that equals -3i plus 7j minus 2k. Is that what it was looking for? -3i plus 7j minus 2k. So I've done that. Question C. Calculate the size of angle DBC. Well, where's DBC? D to B to C. So start of the exam paper says that U dot V equals the size of U times the size of V times cos theta. Or A dot B or whatever letters it is. So we've got B to D. And have we got B to C? Yes, we've got B to C. And it wants this angle here in between, angle DBC. So that's what we're looking for. So let's call that my U and that my V. So our U is our BD. So B to D is -3, 7, -2. And our V is our BC, which is -4, 9, -5. And U dot V is start of the exam paper is the size of U, the size of V times the cos of theta. So rearranging that, cos theta is U dot V over the size of U, the size of V. So what's U dot V? Calculator time. You've got -3 times -4 is 12, plus 7 9s is 63, plus -2 times -5 is 10. That is 85. Over, there'll be a square root and a square root for the size of U and V, and the size is just done by doing that squared plus that squared plus that squared square rooted. So 3 squared plus 7 squared plus 2 squared. We can ignore the signs because when you do a minus times a minus you get a plus. So the first one's root 62. And similarly, we've got 4 squared plus 9 squared plus 5 squared, which is 122. So inverse cos to get theta. I'll just use a calculator. So shift cos 85 divided by bracket root 62 times root 122 is about 12.2 degrees. And we're done there. SQA Higher Maths 2025 Essential Skills Paper 2 Question 9. A cylindrical tub of sweets has a volume of 200 centimeters cubed. The radius is r and the height is h. Show that the surface area is given by that formula. So surface area, this is going to be an optimization question, of course. If you can't do part A, jump to part B. That's the idea. But for part A, we have got a circle. So that's pi r squared. And we've got 2 of them, one on the top and one on the bottom. And then when you unfold a cylinder, it actually turns into a rectangle. And you can imagine that this bit gets unfolded, so that's pi times diameter. Pi times diameter, and it's by the height. So that means that you've got pi times diameter, or 2 pi r, times h. So you've got 2 pi r times h plus 2 pi r squared is my surface area. But it also tells me that the volume is 200. Well, the volume of a cylinder is pi r squared h, and that equals 200. So I can rearrange that for h because the thing doesn't have h in it. H is just 200 over pi r squared. So that means that my surface area is 2 pi r times 200 over pi r squared plus 2 pi r squared. So what does that give me? Well, pi cancels with pi, and r cancels with an r. 2 times 2 is 400. So that's 400 over r over plus 2 pi r squared. What does it exactly say? It was 2 pi r squared plus 400 over r. So I'm done there. Determine the radius, it will minimize the surface area. So for minimize, I need to differentiate it and find the stationary points, and then find out which one's the minimum, of course. So stationary points occur when a dash r equals 0. So starting off with a of r, 2 pi r squared plus 400, and that'll be r to the minus 1 by taking it up. Getting it ready to differentiate. So a dash r, 2 2's is 4 pi r, take away 1 for the power, so that's just r. Then minus 400, that'll be r to the minus 2. Or if you prefer, 4 pi r minus 400 over r squared. And we're going to see that equals 0. So there's a couple of ways you can do this. You can make a common denominator, is the easiest way to do it, or times everything by r squared, which is what I'm going to do. So timesing through by r squared, I'll times that by r squared, I'll times that by r squared, and I'll times that by r squared. So that gives me 4 pi r cubed minus 400, because the r squares disappear, equals 0 still, because 0 times anything 0. And now that's just an equation to solve. So take out 4 as a common factor. That's pi r cubed minus 100 equals 0. Or divide by 4, whatever way you think. But in any case, you're going to get pi r cubed minus 100 equals 0. So that means that pi r cubed equals 100. So r cubed is 100 over pi. And that means that our r is the cube root of 100 over pi, which we can use a calculator for. Cube root bracket 100 divided by pi, 3.169, so about 3.17 we'll say, and the units would be centimetres. Now obviously that is a minimum, but we need to show it's a minimum. So you do a nature table, or you can do the second derivative, but I'm thinking nature table is what most of us would do. So we're going along, and we're at 3.17, and then we're going along, so we want to pick a number in the vicinity of that. So maybe 3 and 4, and we're going to sub that into a dash r. So remember, a dash r, way back up here, was 4 pi r minus 400 over r squared. Now you can do a lot of this in your head, but I'll show you it here. 4 times pi times 3, say, is that, minus 400 over 3 squared is 9. That's a negative number. So I can just write negative, that's 0. And then 4 is going to be positive, of course, but we need to check just to be on the safe side. 4 times pi times 4 is that, minus 400 over 4 fours is 16. That's a positive number for us. So our shape is down, along, and up. Therefore, 3.17 is a minimum turning point. So 3.17 centimetres minimises the surface area. And we're done there. That's basically it. If it asked us to find the actual surface area, which it doesn't in this case, you would just sub that back into the original equation. SQA Higher Maths 2025 Essential Skills Paper 2, Question 10. Scientists have studied a new strain of healthy gut bacteria. The number of bacteria present is shown by this formula, and it's an exponential formula, where T represents the number of hours since the trial began. State the number of bacteria at the start of the trial. It says state, which implies that you can just put the answer, and the answer is 215, and it's 215 because when you put 0 in the power position, that becomes, the whole of that's just 1. So it's 205 times 1. How long will it take for a trial to reach 1,000 bacteria? So for part B, B is becoming 1,000, and that equals 215 e to the 0.166t. This is quite a nice one, this one, because there's no k to deal with. So it's just take the 215 down, e to the 0.166t, and then log both sides. To get rid of a power, you log Because the reason you do that is you can then use the rules of logs and take the 0.166t in front of log, and the log of e, same base, is 1. So that means that t is equal to the log of 1000 over 215, all divided by 0.166, because that log e is just 1. I'll put that beside in case you really need it. So we'll just get a calculator and work it out. ln, bracket, I've already got a bracket, 1000 divided by 215, press equals, divided by 0.166, and I get 9.259 or 9.26. And what is the units on this? Hours. It doesn't ask me for hours and minutes or anything, so I'm quite happy with 9.26 hours. But if you did want it in hours and minutes, just to be complete, 0.26 times 60 minutes, so about 9 hours and 15.6 or 16 minutes, say. But I think you'll be fine with 9.26 hours for this question. SQA Higher Maths 2025 Essential Skills Paper 2, question 11. Two variables x and y are connected by y equals ab to the x, and you've got log 8y shown, and you've got x shown, and you've got 2 and 9, 5. Find the values of a and b. Now I always start this from the beginning and work through it. So I always start by saying, well, look, I've got y equals ab to the x. So that means that I've got log base a of y equals log base a of ab to the x, because it's base a in the question. So log base a of y equals, now we're going to use the rules of logs to separate this out. So I've got log base a of a plus log base a of b to the x. So that means I've got log base a of y as log base a of a plus x log base a of b. Now let's write that as the x first then. We've got log base a of b all times x plus log base a of a. Well, that's a bit like a big Y equals mx plus c. It's a bit like that. So that's our y. Well, that's good because that's the y-axis. X is just x, which is great. Gradient is this, and c is where it cuts, which is here. And we know that c is log base a of a. So we can then work on this. So back up to here, we've got to 0.02 and 95. So our gradient is y2 minus y1 over x2 minus x1, 3 over 9, which is a third. And then our y-intercept, since we're given it in the question, is c equals 2. So we can now just say that log base a of b equals 1/3, and log base a of a equals 2, and solve for both of them. So to solve this one, 8 to the power of 1/3 equals b. So that means that b is 2, the cube root of 8. You can use a calculator for that if you want. And 8 squared equals a, so a is 64. And what do we want to write it as? Find the values of a and b. Well, I've done that, so I'm done there. Maths 2025 Essential Skills Paper 2, question 12. Express root 3 cos x plus 2 sin x in the form k cos x minus a, and it's in radians. And then find the value of t, where 1 is less than t is less than 3, for the integral of 0 and t of this. And it says it equals that. Right? We'll get to that in a minute. Let's do part A, which is the wave function. So we've got root 3 cos x plus 2 sin x equals k cos x cos a, start of the exam paper, and then the sign changes on the cos one, so plus k sin x sin a. In front of cos x on this side is root 3, and in front of cos x on that side is k cos a. So I can write k cos a equals root 3, And then we've got a different colour. In front of sine x on this side is 2, and in front of sine x on that is k sine a. So k sine a equals 2. Now we can work on this. We can work out our k, because if we square it, we get sine squared plus cos squared, which is 1. So that gives you just Pythagoras. So straight away, you can just write that k squared equals the number squared, which is 2 squared plus root 3 squared. So that gives you 4 plus 3, which is 7. That's k squared. So k is root 7. And then we need to find tan a, which is sine divided by cos, 2 over root 3. So I'll do the inverse tan of 2 over root 3. Working in radians. That's 0.857. Using a cast diagram to confirm where it is, well, the original cos equation was positive, and the original sine was also positive, so it is the first one. So a is 0.857. So I've now got root 7 cos x minus 0.857, and I'm done there for part A. Let's move on to part B. Part B says, hence find the value of t between 1 and 3, such that the integral between 0 and t of, well, it's 2 cos x minus root 3 sine x dx is equal to that. So we're going to integrate that and see what happens, see what we get. So the integral between 0 and t, 2 cos x minus root 3 sine x dx equals 0.385. So let's integrate that. So that equals 2 sine x, because cos goes to sine, so that exam paper. Sine goes to minus cos, but I've already got a minus, so that becomes a plus root 3 cos x between 0 and t. But 2 sine x plus root 3 cos x was the original question, so I've changed that already into root 7 cos x minus 0.857. So I can just write that. So that equals root 7 cos x minus 0.857 between 0 and t. And that all along equals 0.385. That's what we're told. So then expanding this one out, I've got root 7 cos x is t minus 0.857. Take away root 7 cos x is 0 minus 0.857 equals 0.385. Quite a trick question, but let's work out cos of root 7 times cos of, well, 0 minus 0.857 is minus 0.857. That's 1.732. So we've got root 7 cos t minus 0.857 minus 1.732 equals 0.385. So root 7 cos t minus 0.857 equals, adding the two numbers together, 2.117. So that means I can work out what the cos of t minus 0.857 is. It is 2.117 divided by root 7. So I can do the inverse cos of that. Inverse cos 2.117 divided by root 7 is 0.643. So we've got a cast diagram to see how many solutions, and let's see where it is between. The value of t is between minus 1 and 1. So we might only need one answer here. But our cos is positive, so that's 2 pi minus. So we get t minus 0.857 equals 0.643, or t minus 0.857 equals 2 pi, I can already see that's going to be too big, minus 0.643, which is 5.640. Solving both of the equations then, that implies that one's going to be invalid because t is going to be too big. T equals 0.643 plus 0.857, 1.5 roughly. That's nice and neat, isn't it? And is it in any particular units? Nah, just 1.5. So we're done there. This has been Clever Maths. Today we did SQA Higher Maths 2025 Essential Skills Paper 2. Hopefully you found that useful. If you did, give it a like. And remember, we are doing a last minute live stream the night before the exam, but you need to be a member. So click join now to become a member. Take care, stay safe, and goodbye.